Hi everyone, this is a video for the FSCI course on extracting, pulling, wrangling data from the Crossref and ORCID APIs using R. The focus of this session is on extracting data using lists. This is really important because the data that comes into R from the APIs requests that we're making come in what's called JSON or JavaScript Object Notation, JSON file formats. And this is a way of allowing data to come back in nested lists, which is a concept that we'll be discussing in the course of this video. And the way that R treats JSON is it's kind of got its idiosyncrasies, but there are some functions that help us to simplify that. So I've made this video optional because a lot of the functions that I provide you in those lessons don't require a deep understanding of these concepts. But if you're going to go forward and write your own custom functions to get data from the API calls that you make, then it will be helpful for you to wrap your head around some of these concepts I'm going to show you in this video. This video will also go over the map functions, which are included in the purrr package, P-U-R-R. This is a package that is another add-on package to R. And what map does is it allows you to write loops to do something multiple times to a set of data. For example, to execute a function on each item in a list in order to extract the data out of it. So all of this will hopefully start to make a little bit of sense once we get into the lesson. So I'm going to go ahead and share my screen. And I'm going to turn my camera off. All right, there are two ways of getting at the contents for this class. One is to go to the course website, and this lesson is under Exploring Data in Lists. I am going to launch the notebook from the course web OSF site, so I'm going to go into day 2. I am going to read more from the wiki. And I am going to launch the Jupyter Notebook for exploring data and lists. One difference between the two of these is on this website, I'm able to visualize the nested lists that we're going to be talking about here. And that's not something that can be done in the Jupyter Notebook. So I'm going to be jumping back and forth from the Jupyter Notebook into this website to illustrate some of the concepts. This particular lesson was created by Jenny Bryan, and it's available here. She graciously distributed it under the terms of a Creative Commons license, which allowed me to adapt it for this lesson. I put it in, I changed a couple of things, added to it, and removed a little bit. And I also put it into the format of a Jupyter Notebook to allow you to execute some of the code. And so thanks to Jenny for providing the structure and framework of the lesson. And the binder is still going. Let me check on these logs. Should launch here in a second. There we go. Alrighty, so I'm going to start by loading the packages that we're going to need. I'm going to do that by pressing Control Enter. Purrr is going to be the series of functions that have map and pluck, which are two of the functions I'm going to use through this tutorial. Recursive is a set of example recursive list examples that Jenny Bryan has created for R. List viewer I'm not using in the Jupyter Notebook, but it's what is used to view the lists on this website. And then dplyr is our friend from the video on data exploration, and that allows us to manipulate data. Okay, so let me quickly help explain the concept of a list in R. We talked last few sessions about a vector. A vector is kind of the most basic object, and you can think of it as like the column in a data set. Then we also have a data frame. A data frame generally consists of a series of vectors, all kind of glued or bound together to create a data set. So a list is a little bit different. A list, when it comes to vectors, everything in the vector has to be the same type. It's what's called homogeneous. So a vector of numbers has to be a numeric type. A vector of characters has to be a character type. And then within the data frame, the same holds true. For that data frame, each column, each vector has to be the same type. Well, with a list, any item in a list can be any kind of object. So in other words, you can have a list that has just one letter and then has an entire data set, like an entire huge data frame, could be the second object. And then the third object in the list could be a bunch of numbers. The fourth object could be dates. So lists are ways of kind of carrying a lot of data of different types in one place. So the way to kind of think of that in your head, I'm going to scroll down to this Game of Thrones characters. So if we look at the first object in this list, we'll see we've got a URL, we've got an ID, we've got a name. Then we come down here to titles. Well, this is a list. So this is a list of titles within the list of this first character in Game of Thrones, Theon Greyjoy. So then aliases, we also have another list. And we have which books he's in, which is another list. To make things even more complicated, I'm going to give you a sneak preview of our Crossref. And I'm going to scroll down to here. So this is the result of a an API call for our Crossref. And here, what we've done is we've asked for a list of publications from the journal +1 with the limit set to 5, which means we're going to get 5 articles back. And so within each one of these list elements, we have five items. So the title of the journal, the date that the article was created, the date the article was published online, the article DOI. Then if we scroll down, these last 5 are what are called nested lists. So if I expand this author box here, I'm going to have 5 items, of course, because I have 5 articles in the list. But when I look under item 1, I see another nested list for given name, family name, and the sequence or the order in which the author appeared. And then it's not until I expand that I get my list of authors. And this particular article, Article 1, has 4 authors. So the reason that I'm including this lesson in your course is because we have to go deep 1, 2, 3 levels into this object in order to get the data out of it. So you have to be able to index deeply into lists in order to return data that we need or that we want. And that's kind of the way that JSON works, is it has these deeply nested lists that contain the good stuff, the data that we're asking for. So we have to know how to work with those in R in order to get the data out. Okay, so I'm going to jump back here and I'm quickly going to review the ways that you can get data out of a list. The first is using the $sign. I'm going to remove this real quick and just print X. Remember, I'm pressing Control Enter there. So here we see X is a list with 2 objects. The first object is called A, and the data within A is the character A. The second object is called B, and the data within B is the number 2. So I can get the data in A out by putting $A and the data in B out by pressing $B. And so look how this changes. This is a view of the list. Now, let me go ahead and just keep that there. Now, when I run this, here's the list. Here's the data in the first item of the list, this A, not the A that the list is called, and then number 2. All right, so $ is one way to get the data out. Double brackets are another way of getting the data out. So with double square brackets, it goes into the list itself, and it extracts the data from it by name or position. So I could do X double brackets A to get this A out, and this is kind of confusing potentially, but it's going into A and it's extracting all of the data that is called A. I mean, it's going into X and extracting all the data called A. Don't worry about it if this concept is difficult to grasp. I've been using R for almost 10 years now, and I still have trouble sometimes wrapping my head around it. And then finally, you can use a single square bracket. I'm just going to review this real quick. If you have a list, so here, the first item we got is the list item called A. So we got the list item called A, and we got the data in A. The second one, we combined A and B. So this is really just a replication of the list. And then the third example here, we pass it a vector false true. So then in that case, it's not giving us the first list item, it's giving us the second list item. So the reason that I went through that pretty quickly is because what we use in these class tutorials is the function called pluck. And that is a more useful function, I think, for getting data out of deeply indexed lists than using these ones above. So here's an example. Object 1, obj1, is a list. That list consists of 2 items. The first item is just the letter A. The second item is another list. That list is going to be called my list, which is right here. So, and that list contains 2 elements. It contains the number 1, and it contains a character called foo, and the name of that character is ELT. All right, so the reason that that has a name is because I could have included like multiple items there, and then it would still be called ELT. But I'm not going to do that. I'm just going to keep it the same. So I could have also added another item in this list that was a list. So we would have a list and a list and a list. Is your head hurting yet? But that's what you get when you're working with APIs. So I hate to jump you in the deep end here talking about really complex nested lists, but that kind of just goes with the territory when working with APIs. So we create a list that we assign to obj1. We create another list that looks almost the same. It just has a B instead of an A, and it has a 2, and it has a bar. And then we combine those 2 into another list. So it's going to look like this. X is a list of 2 objects, 2 items, 2 elements, whatever you want to call it. The first object has the first part of it is a A, and the second part of it is a list. And within that list is number 1 and the word foo, which is given the name under the name ELT. So what pluck does is it indexes into the list by position, just like the double brackets. It just makes it kind of more explicit. So if I was to pluck from X, number 1, I am going to get this entire first list element. All right, so let's see what that looks like. And we see it's just that first item. Okay, if I was to put 2 in there, then we get the second list item. And I encourage you to play around with this stuff. So if you want to add in your own code and just experiment, you can do that. Okay, so what if I wanted to get the A or the second list item out? Well, if I wanted to get the A out, then I would do, I would pluck, I would go into X, I would go into the first element, and I would get that first element out. And you see that is right down here. Okay, so that's why pluck is much more functional. Now, what if I wanted to get the word, the number 1 out? Well, in that case, I'm going to have to go into X. I'm going to have to pluck it from X. I'm going to have to go into the first item in X, which is this. Then I'm going to have to go into the second item in X, which is this list. And then I'm going to have to pull the first number out, which is that number 1. So, so that's how that works. And you can also supply names to the named vectors. So you can say pluck X, go into the first item of X, go into the second item of that first item, which is my list, and then pull ELT out. And that would give you this FOO, because that's what ELT, this object is named. The second item of this list is called ELT. Whew. It's very confusing, but again, if it doesn't stick, if you don't get it, then don't stress out too much about it. So there are a couple of examples that are in the recursive package, which I'm going to jump back into here. Sorry. One of them is color palettes from Wes Anderson films. I'm not going to spend time on that. Another one is these Game of Thrones characters, which I've already shown you. And then another one is GitHub users and repositories, which I'm also not going to go into. But if you want to play around with those, feel free. All right, so let's talk about what she's showing here is that we can use stir to give us like a sneak peek at what's in a list. So this stir looks at Game of Thrones characters, and it gives us the first 3 items in the list. And those first 3 items are each themselves lists, and those lists each have 18 elements within them. So remember list.len to get that data. All right, let's talk about vectorized and listized operations. Remember in our first couple of sessions, we saw that R is vectorized. The example that we gave was if we gave Y 5 and we gave Z 5, 10, and 15, and then we added Y plus Z, we can see that it's vectorized. It adds to the longest element, it adds the shortest element, 10, 15, and 20. Well, that works with all different kinds of mathematical operations. So here we have, when you see that colon, that means consecutive. So the numbers 3, 4, and 5 to the square root, squared to the second power. So 9, 16, and 25. And the same applies if we pass a vector of numeric vector of 9, 16, and 25 into the square root function. We will get the square root of each one of those numbers, 3, 4, and 5. So typically what we're going to be using the map function in this and in our other lessons. And what map does is it takes this bulky, long and slow for loop and makes it short and much more efficient. Okay, so this is an example of what a for loop looks like. If you run it, it's going to give you an error. It's just an example. So what map does is it kind of makes the vectorized operations explicit, because sometimes you need to specify when it comes to a list, it's not straightforward to vectorize your operations. You have to be more specific. So this is an illustration here of of the way that map works. It takes as its first argument whatever you want to run a loop on. So in this case, we're running a loop using the numbers 9, 16, and 25, the vector 9, 16, 25. And then the second argument to map is what function do you want to apply to each item within that, whatever you pass to it, whether it's a vector, a data frame, a list, which is what we're going to be doing. So here it's doing what we saw above, right? Taking the square root of each one of these numbers. So this is a simple example to illustrate the concept. But when we get into the list, it's much more complex. So first of all, what you if you want to extract an item, you can pass as the second argument to map the name of that item. So going back here to our Game of Thrones, we can see that each one of these is a different character. So this first character is Theon Greyjoy. Second character, Tyrion Lannister. Third character, Victorian Greyjoy, etc. Okay, so what we want to do is we want to extract the names of all these characters. So you can see there's 30 different characters here. So that's where map comes in handy, is I can say map Game of Thrones characters, and let me just take this off just to show you. And it will give me all 30 names. The reason that that was there was just to save space and just give us the first 4, right? So, and essentially what this is doing is it's applying this, it's plucking, basically is what it's doing. It's plucking the name from each one of the list elements. So this is effectively what it would look like if we made that explicit. Map Game of Thrones characters using the pluck function, using the name, getting the name, plucking the name out of it. So we can also use position shortcuts, numbers, like we did above. So in that case, name is the third element. And here we're lucky because all of this data is standardized. It's precisely the same. So we can use the number 3 as our index, and it's going to extract the name each time. Sometimes when you're working with API calls, that is not the case, and you cannot use numeric indexing, and you should use name indexing when available, because if you use a numeric index and the data is different, well, then you're going to be pulling junk for the data that's different. But in this case, we can pull using the number 3, and here we'll pull it from characters 5 through 8, and we can see we have a different set of names. So you're often going to use map used together with the pipe, and that's what we're going to do in the R Crossref and our ORCID lessons. So you'll remember from the data exploration lesson that what the pipe does is it takes the it takes the output of the previous function and it feeds it and uses it as the input of the next function. So this is taking the Game of Thrones characters list. Then remember, in your mind, always think of the word then when you see a pipe. Take the Game of Thrones character list, then apply map to that list and pluck the name character. And what I do to make things more straightforward when I'm writing map in the lessons that I gave you is I will actually add a period here to the start. This is exactly the same. You'll see that the data does not change at all. This is going to print two sets of names, right? Exactly the same. So you'll see that the data doesn't change when I put this period in there. All that the period does is it says whatever the input was, whatever the output was as a result of this pipe, which was the list, use it as the input for here. So it's just making it more explicit that we're running map on the output from the previous function, which is the Game of Thrones character list. So there's some exercises there if you want to run through those. I'm not going to go into them here. So, okay, map always returns a list, but sometimes you're going to want to get a vector and not a list back. And for that, we have these specific types of map functions. So map chr is a character. And let me show you what I'm saying here. If I was to do map Game of Thrones characters and say name, and I want to get the class of this, it's gonna give me a list because map always gives me a list. So even though it looks like I got the names, that's actually a list of names. It's not a character vector of names. Okay, we have to use map chr to get that into character vector. And you'll see when I run class on that, it's telling me it's a character, not a list. Now that's a little bit of nuance that, again, it's okay if you don't understand what I'm talking about there. It's not essential to understanding and running the functions that I'm going to give you. So there's also, in addition to map chr, there's map logical, map integer, and map double, each of which gets a logical character, I mean a logical class, an integer class, or a double class, which is a type of numeric vector. So there's a couple of exercises here, which I will run through if you want to try it out. They're a bit challenging, I realize that. So you can try it out, or you can just watch me give you the answers, which I'll do right now. So it says for each character, meaning character in Game of Thrones, the second element is named ID, as we can see here, ID. This is the character's ID in the API of Ice and Fire. Use a type-specific form of map and an extraction shortcut to extract these IDs into an integer vector. So it's telling us that ID is an integer. So in that case, we're going to use the map int function, map int, and we're going to do that on Game of Thrones characters, and we are going to pull the item ID. And there we have our character IDs. We can jump back in here and see Theon's ID is 1022, Tyrion's ID is 1052, and that's what we see here for all 30 characters. This next one's a bit tough, and I hope I remember how to do it. Use your list inspection strategies to find the list element that is logical. So that one's a toughie. To do that, we're going to run map character on Game of Thrones characters. Let's see. I think, let me see. Okay, no. What this is telling us is I'm looking at the list of Game of Thrones characters, and I want to know the class of each one of those items, and it's telling me all of them are a list. And that, what that is saying is that each one of these 30 items is a list. So that's not going to tell us what each of the types are here, where here, remember, we have, this is a character, this is an integer, this is a character, these are all characters, and then titles is a list. Okay, so to get that, what we have to do, it's a little bit tricky, is we have to extract from the first item in the Game of Thrones characters list. Okay, and that will then tell us that it's the URL is a character, the ID is an integer, name is a character. And the reason that I did map CHR is because this output here is a character output. It's not a list. I could actually have just run it like this, and that would give it to me in list format. Okay, so the challenge is to find the list element that is logical, which means it's true, false. And we go here to alive, and that is our logical. True or false, are they alive or not? So if you don't want Game of Thrones spoilers, I think this one is several years old, but you can skip this part of the video. So is the character alive or not? So then the challenge is use a type-specific form of map and an extraction shortcut to extract these values for all characters into a logical vector. So what we want to do there is use the map LGL, map logical function to Game of Thrones characters. Now we're going to apply it to all of them, not just the first item. And we are going to extract alive. And let me comment this out just so we can see the results. And we have true, 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 false, true, false, false. And I suspect by the end of the show, most of these are false. I still haven't seen the last season. That's the way that this works with when you specify the map type, that's the output that you're going to get. Okay. Now, what if you want to extract multiple elements like the name, the culture, the gender, and the year that they were born? Well, here, this is the traditional way to do it, where I'm calling Game of Thrones, I'm getting the third character element, who is Victorian, and I am getting their name, culture, gender, and born. Right. That's the way to do it with brackets. To do it with map, remember map, what's our data, what's our function, and what are any arguments that we're passing to that function. So here we can use the bracket, the single bracket within the backticks, which it's the character next to the 1 on the keyboard. So there we can say that's a sort of extraction. So here we are extracting from Game of Thrones characters the name, culture, and gender using map. And it's printing out here the list of the number 16 and number 17 to show us the results of that. So again, it's basically the same thing, but when we get into more deeply complex nested lists, it's good to use map. I'm gonna skip this section right here and finally move on to data frame output. And what I mean by that is, so we have this complex nested list, but let's say we want to get it into a nice, neat data frame with rows and columns and so on. So with that, we use the map type map DFR, map data frame, and then R stands for rows. So in other words, it's going to go through each Game of Thrones character. It's going to use this function. Don't worry about what that means. That's just a function from another R package. And it's going to extract the name, culture, gender, ID, born, date, and alive, yes or no. And then it's going to bind together the rows for each person. So that's what we want to see. And that's where we want to go with all of this, because that lays it out much more clearly for us. And we're much more comfortable looking at a flat data frame like this. So Jenny Bryan writes, finally, a data frame, hallelujah, I agree. And she said, notice how the variables have been automatically type converted. In other words, if we were to run stir on this, let's just wrap it in. We would see name comes in as a character, culture as a character, ID as an integer, which that's good. I'm gonna get rid of that. That it's a beautiful thing until it's not. And she says, when programming, it is safer but more cumbersome to explicitly specify the type and build your data frame the usual way. And you'll see when we get into the R ORCID lesson that we use this method extensively. So here you're going bit by bit, and it's tedious, but it's a way of being very precise and making sure that your output is exactly what you want. So here what we're doing is, so she's calling the Tibble package, which is part of the tidyverse, calling Game of Thrones characters list, then, and then putting a brace allows you to specify and construct by hand a tibble. I don't think I talked too much about tibbles in the last lesson. Tibbles are just the tidyverse's version of a data frame. So just think of a tibble as a data frame or a spreadsheet like you would see in Excel. Okay, so these are, each argument to the tibble is a different column in Excel. So the first column is called name. And in name, we use the map CHR, which gets the character values. We specify the input, which is the Game of Thrones character list. We use the function pluck, and we pluck the name out of each of the elements of the list, all 30. Do the same thing for culture. And what this allows us to do, you'll notice here when we get to ID, we specify that we want an integer with map int. And when we get to alive, that we want a logical with map LGL. And when we run this, we have what we saw above, only we can be confident that we have specified our construction deliberately. And the other reason to do it this way is, as you'll see in our ORCID, in fact, let me just jump over into that, what it's going to look like. Let's see here. So this monstrosity is where we're going with this. Where we are going into the ORCID list, we're going into the name element, the created date element, the value element, and we're extracting the value element. So this is the complicated mess that makes using pluck necessary, and why we want to specify each item that we want to return and construct a tibble manually that way. So the last challenge is use map DFR to create the same data frame as above, but indexing with a vector of positive integers instead of names. So what I would do there, I mean, not sure why I created this exercise, but I'm not sure what the point of it is. So we would look at what the item names are and just type the numbers in. And there's a way of printing out those numbers, but this video is long enough. So that is pluck, map, and lists. Again, this video was optional. The more you can understand it, the better you'll be able to handle complex data in lists. But if a lot of it was over your head, don't stress out about that. And feel free to come back and visit this video and go through some of these exercises yourself.